Hello everybody, welcome once again. Here is Rajesh of YouTube channel. So now today we will discuss about the circles. And as we were discussing about the circles, and that's different shapes and single circles we are taking here to prove that it's a cards, it's a arc, it's a radii, and simply it's a triangles and angle subtended on the center of the circle and subtended on the any cards are two triangles forms on same card or same arc. Then what will be different types of the criteria we have discussed here and approved here. So but today, so now we will discuss about the criteria associated with the two congruent circuits is given here. So are suppose that some uh, some result on a congruent circle is given here. So with the help of congruent circles, so we will discuss about the and try to try to solve and prove the different types of the theorems. So here is the theorem. First, suppose that we are going to take the theorem first. So take the theorem first. Here we will take the theorem first. And theorems. Okay. Theorem 30. Okay, theorem 30. It is said that if the two arcs of a congruent circle are congruent to arc of a congruent circle are congruence, then the then the corresponding chord are equals. Okay, then the corresponding chord are equals. Okay, here. Okay, given we will first write here given as we are doing given givens. In a givens we will write here two congruent circles, two congruent circle COR and CO dash R, in which okay in which arc AB is congruent to arc CD. Arc AB is congruent to arc CD. Okay, so we have to prove that given. So we have to prove here, sir, to prove that AB chord AB is equal to chord CD. AB and CD is equals. Okay, so first of all, so we will draw here a circle. This is circle. Okay, circle in which O is centers, and suppose that this is a chord AB, and the second circle we will draw here. This is second circle. It is center O dash, and the chord. Suppose that chord is here CD. Okay, so cards we have drawn here, so a circle ABCD we have drawn here. Got it? So we have drawn here. So to prove that, now constructions we will construct here. Construction. What is constructions? According to construction, draw a line segment. Draw a line segment OA OB. Draw a line segments OA, OB, O dash C and O dash D. Segment OA, OB and O dash C, O dash D. we have drawn here as one by one we are drawing and showing you. So proof in case first. What is case first? Case first is telling that so when AB and CD are minor arcs, when AB and CD are minor arc. Okay, ABCD are minor arc. Then we will take the triangles. Then in triangles OAB and O'CD, we will take here triangles and OAB, CO'C. We have some. Okay, we have what we have. We have AO is equal to CO dash. AO is equal to CO dash Y. We know that AO is equal to CO dash Y is equal to R. Radius, same radius, equal radius, and OB is equal to O dash C. BO is equal to O dash C. BO is equal to O dash D. Because equal arc are same, as we are discussing here, arc are same, and angle OB, AOB and angle AOB is equal to angle COD, CO'D. Why? Because it's a reason that arc are equals and angles are equals. Arc AB is congruent to arc CD and angle I have put here angles angle is equals, so arc AOD and angles AOB is equal to angle CO dash. Angle AOB is equal to angle CO dash D. Okay, so both are equals AOB CODs. So AOB is equal to COD. So angle AOB is congruent, so it became congruent. So angle AOB is congruent to side triangles CO dash D. But it's by criteria. Suppose the side angles. Okay, we will write here which criteria SAS side criteria, and therefore we can say that AB is by SAS triangles, and hence AB is equal to CD. Chord both parts are equal to CD. So we will take the case second. What is case second? In case second, suppose that we are taking that's when AB and CD are major arc. When AB and CD, arc AB and arc CD are major arc. Okay, AB and CD are major arc. Then in the same case we are minor arcs. Then in same case AB and CD are minor arc. This become minor arcs. Got it? AB and CD are minor arcs. Then AB is congruent to CD arc. AB arc congruent to arc CD. Got it? So AB arc CD. So AB is BA arc R is equal to BA arc is equal to congruent to DC arc. Same as reverse. So DC arc we can say that. So BA is equal to DC. So BA is equal to DC. BA is equal to DC. So AB is equal to CD. So AB is equal to CD. Got it? So AB is equal to CD. We have done here, and AB is equal to CD. These are the case seconds. Got it? So these are the angles we have proved here, so by means of one by one process. Now suppose that here is the some questions also given you, different criteria given here, so, and we have to prove that in if two chord of a congruent circle are equal. Okay, second theorems in terms of, we can say that theorem 14, if the two if if the if the two chord of a congruent circle, two chord of a congruent circle, two are chord of a congruent circles are, okay, two chord of congruent circle are equal, then the equal, then the corresponding arc are equals, and congruence this we have to prove that, so equal and congruence are equal and congruence, and that may be major arc, that may be major arc, minor arc are equal diameter, means that same radius. Okay, so equal arc, a major arc, minor arc, and the equal arc are semicircles, or we can say equal diameter or semicircle circle. Okay, so here is the questions, and in this questions case is given here, so we have to prove that, so given is there, suppose that two circles, so we have to draw two circles. So given, before writing givens, first of all we will draw the two circles. Suppose that first circle and the second circle is here, O dash, and this is arc AB and arc CD. AB and the CD arc is given here. Okay, so given in a circle, given is given two congruent circle, given two congruent circle, code O R and C O dash R, in which two congruent circles given here, so in which it's a given two chord or congruent circle is given, in which we can say that here is the in which in which two chord of a circle, in which its a chord is given here. So we will discuss here in which okay, so in which two congruent circles you are, in which chord AB chord AB is equal to chord CD. It's a given. So constructions, we will constructions, sorry, two proofs. To prove what to prove? It's a proof that's arc, means that's we have to constructions, and the case if construction, if AB and CD are not diameters, if AB and CD are not a diameter, okay, AB and CD are not diameters, then draw a line segment OA, then we will draw a line segment OA, this is OA, OB, O dash C and O dash D, OA, OB, O dash C and O dash A, O dash D. We have drawn here an arc, sorry, we have drawn here, so we have to prove that, what to prove that AB and CD are equals. So constructions, Here is constructions. We have right here constructions. Then we have to prove that AB chord is congruent to CD chord. Okay. So here we have to prove. So we will write here. So we have to prove this one thing. So we have to take the case proofs. Right here, prove case first. What is case first? It's if the when the AB and CD are minor. When AB and arc CD are minor arc, then what we will do then in triangles? We will take the triangle AB, then triangles AOB and COD. we will prove here OA is equal to OA is equal to O dash C is equal to R, equal radius, and OB is equal to okay, OB is equal to O dash D because equal radius, and AB is equal to AB. It's a given equal chord. In the question says it's a given. So triangles AOB is congruent to triangles COD by criteria. Yes, and angle will also be angle AOB is equal to angle COD by criteria CPCT. Got it? So criteria, so we have written here CPCT. So criteria CPCT. So we can say that minor arc AB is congruent to minor arc CD. Got it? Minor arc AB is congruent to minor arc CD. So arc means that, so we can say that arc AB is equal to arc CD. Okay, these are the case first, and suppose that we are taking the case second. In case second, suppose that case second, we have taken case second. What is case second? If we are taking the case second when AB and CD are major, when AB and CD are major arc, then we can say here that AB and CD are major arc, then in case will be the minor arcs, then AB, then BA, arc BA and arc CA is minor arc. Both are major, then it will be a minor arcs, and minor arc, then AB is equal to CD, then AB is equal to CD, and BA is equal to DC. Got it? BA is equal to DC. So minor arcs AB is congruent to minor arc AB CD. Okay, minor arc CD. So we can say that's 360 minus minor arc. So we will subtract here minus BA. Arc BA is equal to minor arc 360 minor arc CD DC. Arc DC. Got it? Arc DC. So we can say that some minor arcs BA is equal to arc CA CD DC. Okay. DC, and therefore congruency is proved here. So in case of third, suppose that in case of thirds we are taking the in case of third, what we will do that in case of third, we are taking in here, here is in case third. What is case Suppose that in case of thirds, when AB and CD are semicircle, when AB and CD are semicircle, then what happens? If AB and CD are semicircles, then we will say that in this case AB and CD are semicircle of equal radii. Then AB and CD are semicircle of equal radii r. Already given the equal radii r, so we can calculate. So we can say this, and therefore they are congruent. Therefore they are congruence. So we can say that AB card AB are, so arc AB is equal to arc CD, and AB is equal to card CD and congruence to prove. So three cases we have involved here, and the converge of the theorems we have given here step by steps in case of third, case of second, and case of first. We have given you so that you can understood it. I have given you all the questions and it's a related criteria to understood you one by ones. Here's one by ones I am describing with the help of the figures, and the second figures we have also given here, so that you could understood it well. And I hope that you will certainly understand one by ones. A link is given below also. If any problems is associated with these circuits is in your minds, okay. So observe these all the knowledge and keep it in mind, and to improve your comings, careers, and also future, okay. Don't forget to subscribe my channel, okay. Thank you very much. Bye bye.